Okay, yesterday we stopped at example 7. What we have learned so far is zero force member, and how to find zero force member. If you have two member, member 1, member 2, you have two member of truss and no external forces acting, then there will be they are zero force. Another method is three member, and two of them are collinear. Collinear means in the same line. It is a non-linear, non-collinear. Okay, so these are the two ways of finding zero force member. Then yesterday also we learned either the member in tension or in compression. Okay, so this one by identifying. Okay, first you simplify the truss structure, means you remove zero force member. After that, you do the external force analysis with free body diagram, right? All the force equals 0, all the moment, if you need it, then you use all the moment equals 0. Number 3, then you start to do there are two approach. So one is you use the pin analysis, pin or joint analysis. Okay, you look at the pin, what happened to the pin. So the pin, you have compression and tension also. This one is to the pin. And then at the end, as a conclusion, you need to tell me the member. You need to draw full expanded free body diagram with pin and member. Right? Then tell me which one is C, which one is T, the member, not pin. Okay, so this will be what we learned so far. Okay, so there are two method. One is pin joint method. Another one is you cut the things lah. You cut the thing section, cross section method. Okay. All right. So this is what we learned so far. Today we learn. Okay, so there are some example lah in the slides or in your tutorial question. There are some many example you can go and try out. Today we learn into space truss, which is in 3D, three-dimensional. Yesterday class is in 2D. Today we learn about 3D. So 3D, when we see 3D structure, we also call them space truss, as what you see on the diagram here. This will be the simplest form. Of course, you can extend the shape from the shape. Right. So this is tetrahedral. Also the simplest form, if you use the simulation, finite element analysis software, they will start with this simplest form. So you can see all these this simplest form in the building structure almost everywhere, because they are light and they are very easy to assembly. So another one is the cable, the trusses for the electric cable. Right. Okay. Now, what is important is that for this class, you should know how to do analysis, right? So assumption for the design is that the members in the space truss, they are treated as two force member again. So if you're not sure what is two force member, you need to go back and read the PowerPoint slides, right? Provided the external loading is applied at the joint. So these are the joint. These are the joint. And joint consists of ball and socket connection. So all these are procedure, very lengthy, you can read. Basically, it's the same like what you learned. Now, because it's 3D, you look at z-axis, x, y, z. Okay, add one more. F, all the force equals 0, but add one more z-axis. All the moment equals 0, add one more z-axis. Okay. Example 8. Determine the force act in the members in space truss as shown. Indicate whether the members are in tension or compression. So as you can see here, it's a simple truss with a few members there. There are two external forces, 4 kilonewton and 4 kilonewton at point A in the y direction, 2 kilonewton in B in z direction or negative z direction, right? So you're given the positive direction of x, y, and z. You're given the origin of the structure, which is in point C. And the length of all the members will be 2 meter. So like for example, AC, 2 meter. And the distance between C and D is 2 meter. CE may be longer a little bit. C to E horizontal is 2 meter. So basically, you can use cosine rules or you can use right angled triangular if they are 90 degree to solve the question. So we start with point A. We start with point A. Why point A? Because point A is on the axis. It's more easier to do analysis, and you have a known value there. Right. Previous class we choose two members with a known value. Now because it's 3D, we choose a point with three member there and with a known this one. So these are the steps we are take. There are one known forces and three unknown forces. Yesterday in 2D, we take one known forces and two unknown forces. Okay, so how do you draw free body diagram at point A? So you focus on point A. And then there are three members here. So you draw the direction. AB is y direction. AC is negative z direction. AE is diagonal with 2 and 2 with 2 meter to x, 2 meter to y direction. Okay. Remember the origin is at C and not at A, so they will be direction. So because it's a 3D, we use vector analysis. Okay, because it's 3D, so we use vector analysis. So you will see something like this. So you transform what you see as a point joint A. So P will be 4 kilonewton along the y-axis. And FAB is a member of AB. So just use common sense. If you don't know, you can split all the arrow out everything out first if you don't know, right? So all these things, then write them in the vector form. So vector form, you already know already. This one even come out in your test one, right? So you write F equal to FU, U equal to R divided by R. Okay, so you should know how to do that already. So P equal to negative 4J bracket, curly bracket, because it's going negative Y direction. FB equal to FABJ. So AB is along the Y axis, so it's J. FAC equal to minus F in K direction. FAE because it's not on the XYZ, but it's in the certain angle. So it's FU. So your U can write as R vector R divided by the magnitude of the vector. Okay, so this one you should be familiar already. The rest is just substitution. Okay, the rest is just substitution. The concept is to solve using equation of equilibrium, all the force equals 0, all the moment equals 0, right, at point A. So this one you don't need moment, only all the force equals 0. And then group I, group J, group K together. All the I you group together equals 0. All the J you group together becomes 0. All the K, vector K terms in together then get 0. Then you find the answer. Okay, all right. So this one, if you do the mathematics for FAE, you arrive at this one, right? So this one, IJK in the out term, in the U term, sorry, IJK. Then equilibrium, all the x equals 0, all the y is 0, all the z 0, because you're using vector. So basically, x is I, y is j, fz is k. So you group all the I together equals 0, all the j together equals 0, all the k equals 0. Okay, so at the end, you get FAC 0, FAE 0, FAB equal to 4 kilonewton with this FAB here. So because it's pull out, so you pull the pin A or joint A, you pull, it becomes tension. So bracket T. Yeah. So if you see FAC, FAE equals 0, they are 0 force member. Remember? All right. Any questions so far up to here? Anything that you are not sure? Anything that doesn't make sense to you? Okay. So again, just highlight here, don't confuse between the pin that tension and compression with the component T and C. Don't confuse. Okay, once you FB, you move to the next joint. Next joint B. What should you draw for B forces? B is A. A you already have. FAB. So how do you draw the member of this one? Okay. So this one is opposite. This is member AB. So this one you should able to draw in this direction. in the point B is opposite of point A. So point B, you should be able to draw something like this. FAB is opposite because you define the 4 kilonewton. And again, if you are not sure the number that you find, just maintain at FAB over here. Okay. Then there is a force 2 kilonewton along the z-axis to join B. And then there are 3 legs there, right? You have BC, you have BD, you have BE. Again, all this arrow, if you're not sure, just expand that, all the arrow point out, if you're not sure. Then after that, you'll get negative sign. You need to redraw the diagram. If you get negative, if you draw out, for example, FCB, you draw out. In your calculation, you get negative. You need to redraw this diagram. No negative value in the diagram. Okay. Yeah, just have a look. Anything that they are not sure. FBD is straight to the z-axis. FBE, 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 you can write 2, 2. You can write 2, 2. In this case, it already simplified because it's scalable. So here you can write this small triangular here. You can write 2, 2, no issue. Same with this one. Same with BC. BC, you know this is 2. CD is 2. DB is 2. No issue if you write 2, 2. Okay. Yeah. So here, how many unknown you have? 1, 2, 3. You have 3 unknown. 3 unknown, you need 3 equation. Okay. So 3 equation, all the force equals 0. X one direction, Z, X, Y, Z, you get 3 equation. Solve using equation of equilibrium. Okay, so 3 unknown, all the force equals 0, all the force in X 0, all the force in Y 0, all the Z 0. Then you can find the unknown. Okay, same method, just need to solve in the IJK method lah, vector analysis. Okay, so you solve. Okay, you solve. Then you get FBE 0. This one. FBE 0. So FBE 0 means this is a 0 force member. And FCB is positive value pointing into the pin. Of course, if earlier the arrow you point out, you'll get negative value. Remember, when you get negative, remember to flip the value, the arrow, and then also you need to make some clear. So for example, so if you draw FCB like this, at the end, you get SCB, your calculation, minus 5.65 kilonewton. This one is this direction. So you need to change this one. You need to rewrite this one. Positive 5.6 kilonewton. You need to rewrite something like this. Okay, rewrite, then draw back the diagram. Okay, so this one is for this diagram. Then you flip the value to become positive, change the direction. After you change the direction, redraw the diagram. Okay, this is what is expected. So this is how they write. Okay, any questions so far? No. So you through this method, you already found which one is zero force member. So you can answer lah. If the question at the end of the question, just bonus mark, you ask you, identify from your solution or from your analysis, identify which are the zero force member. You just write out which one those that have zero, then you write member BE, for example, and the earlier one. Okay. So you can find other method using join D, join E. Okay. So at the end, you find the answer DE 0, DC 0, CE 0. So with this, any question? No, With no question, we go into frame and machine. Okay, frame and machine is also like a truss, but when you see the frame and machine, the word machine, the one on the left here is a frame. Frame means you have a pole with the cable. So at least you should able to identify what is truss, what is frame. Truss is joined with the pin. Then this one frame is just a member and then joined with the cable. What is machine? Machine, they should have a function there. You should able to function. The simplest one is the plier or scissor, right, or cutter. They are machine. Okay. Okay. So frame machine, there are two type structure. They always assembly by the pin connected multi-force member. Right. What is multi-force? Is member subject to more than two forces. Right. So frame used to support load. Machine is used to transfer and changes the effect of force. So the two different explanation here. Frame is to use to support load like truss and all this. Truss, they are also support load. Machine, they are used to either multiply the forces or reduce the forces. Okay. Okay. So in the free body diagram for frame and machine, the first steps always we disassemble assemble the means we break the component before we solve for the frame and machine. So isolate each part by drawing outline shape and so on. So if you compare the steps compared to the truss earlier, truss we look at pin and joint. Then we transfer the forces into the member. This one, we break them into different parts. Then we identify all the two forces member in the structure. First, you isolate them. Then after that, you find which one is the two force member, and the rest you see lah. Then this one is just the normal things that you do. You just transfer the forces, like for example, the one I draw on the whiteboard here, right? You draw a pin, then member, then opposite force to balance the forces. Okay. So if you look at the question, the diagram, this is a frame, or you can say it's a machine, right? Or you can say it's a truss or something. So in this case, do free body diagram. He asks you to draw a free body diagram for each member, pin at A, B, A and B and A, and the two member connected together. This one. Okay, so for each member means you break them. You don't change the orientation. You just take this one out. Okay. So if you really don't know, when you take before you take out, you remove the connector, remove the reaction force. Means you remove this one, you'll see AX, AY. You remove C, you see CX, CY. Remove these two first. Then you will see two member like this one. This will be the C. After that, pin you remove, then you put in the forces there. Okay, so this is quite direct. When there's a pin, they always have BX, X and Y direction. Okay, so how to get AX, AY? You already learned in the previous chapter. How to get CX, CY? Okay, copy moment, remove pin, you will see X and Y. Okay, X and Y. So what I need to highlight here is the direction. So if you start with member BC, so X to the right positive, going up positive. When you start with the right hand side member, left hand side member must opposite the forces. All right. So for example, BX for BC member, BX pointing to the right. The BX for member AB will be opposite of your BX. Then this one also same. Y also opposite. The blue line here is just saying that the point B here is connected with the pin. Okay. So start from chapter 8, you will see pin join together, and you break them. Use the dotted line to tell that actually this is a connected member. Okay, so this is a new skill for today lah. This one, the rest you already learned already. Okay. So each member you didn't know. So pin at A and B also same. So pin at A and B, this one means you only look at pin and B and A. So you look into three-dimensional. So for example, pin B, you have Y direction, X direction. Okay. So on the left hand side here, these two member is because of AB on the pin. So AX, BY. How you get the direction? You get from here. This is on the member. When you want to see pin, you need to flip the direction. Flip these two direction. Yeah. So if I copy this one, so let's say this is pin B. So if I look at member AB, this member AB, the BY is point down, BX is to this one. So I transfer this one to here. So BX will be here, BY will go up. This is member AB. So you do the same for BC, so same, flip the direction. So again, don't confuse between member or component with the pin. Don't confuse. They are two different sets. So these two are for AB. These two are for PC. Okay. Can pin B okay? So pin A, same also. You flip the A that you draw just now into this one. So this will be AX at the center, AY. This is because of the member. AY and AX is because of member AB. And there are two sides, the connector, the two frame there, they will be forces also. Okay. Yeah. So this is AY divided by half because got two support. So this AY divide by half. This AY, support by two forces at these two hole here. So that's why AY divided by 2. Same with this one. This AX to here, so you must balance. So two more forces at this direction. Okay, because of these two support here. Yeah. If this kind of question come out, you will see, I will show you this orientation. I will remove the arrow. You need to draw the arrow. Okay, so same like this. I will show you the pin shape. You need to put in the forces on the pin. Okay. Right. So you should able to do pin C also lah, if the same thing lah. Okay, two member connected is what you normally works in the previous chapter. Okay, you just see as a one body, copy the external moment and forces, and put in the reaction at the A and C. Okay, then how you solve it, same, apply equivalent equation, all the force equals 0, all the moment equals 0. Then you can solve all the unknown. Yeah. At the higher level, sometimes we just give you a photo and ask you to analyze this section here. Okay, so this is a machine used in the construction site. So there's a conveyor belt, so on. So you are having this structure here. So pin A, B, and then there's a support here. Then there's a belt. There's a belt here, okay, with the angle. So draw a free body diagram of the frame and cylinder that belts around. So you need to break this one into different component. The steps always same. You break into different component. You dismantle the B here, dismantle the A here, and so on. So this is B. And every time got a pin, you have a X and Y direction. Right? So if you don't know, just assume all the forces coming out from the pin. Okay, so BY you can draw up if you want. But you know that if you draw BY go up, it doesn't make sense. All the force cannot balance if the BY go up. Okay, the thing will float up. Cannot, not logic, because the tension is falling pull up. So they must be one force balance these two. So BY pull down. Okay. Okay, then the rest is the rod, you already know. So flip the direction of these two, BX, BY, flip and put in here. Then AX, AY, like normally what you do at W. So of course, AY, if you don't know, you can pull out. If you don't know, because you have W here to balance the BY and BX. So you can pull out. Of course, this drum one is need to be careful a bit lah. Okay, then draw a dotted arrow just to tell that this pin B actually connected the roller here and the body here. Okay. Okay, so this one, if you're given this diagram, you also ask you to draw free body diagram for the entire frame, including pulley and rod. So this one, section A, is actually what you learned previously. See it as one body. Train this connector A as a reaction force, go up, go down. And because it's a pin, no moment. D is tied with the rope. Tied with the rope, there's only one forces here. Okay. So same, this one, pull down. So for A, it should be look something like this. Yeah. Okay, then B. B, the frame without the pulley and cord. Means you remove the cord, remove the pulley, only look at the body. This body. So this body, you will see this got rope, so got pull out, so there's a tension here. Then there's a pin B here. BX, BY. C also got the pin, so got CX, CY. So here got one connector here, tension cable go up. Then this is not the member of the gray color things, so you don't need to draw. A, there's a pin, so AX and Y. Okay, so something like that. Okay, C, each of the pulley you dismantle B and C. Dismantle, you will see BX, BY, but the BX, BY direction, you flip this one. You flip, for example, this one. You flip. If your section B is left and go down, when you do only the pulley, remember to flip. Remember to flip it. Okay, so that's why I show you side by side. Okay, for B, the direction is flip. BY flip, BX also flip. C also same. If your CX to the right, CY go down. When you draw the pulley, flip the CX, CY. And then something missing in the diagram, which is the blue color dot. Okay, connect these two over here and here. Here. Okay. Okay, so far everything is, yeah. No, yeah, the bottom part actually to support the arrow direction. It's just to support whether to check whether correct or not. Yeah. Okay. So basically is this diagram actually is a combination of B and C lah. This diagram. So if this kind of question come out, you just write this one B, this one C. Okay. So this one also same. You go home and read your homework. Okay. Also same. Okay. So just need to highlight when you see a capital G in the diagram, this is central of mass. Always put W at the center of mass. This one will be the careless mistakes usually as you move towards the end of the module, you will forget to put W. You're so focused on the pin, you'll forget the W. Even the question give you the mass sometimes. Of course. So this one will you won't see this one in the question, in the assessment or in the final exam question. You will be given a mass. It will tell you the scope is having a mass of something, mass M. So you need to convert the mass into W. Okay. This also same, your homework, go and see. Okay. Just connect. Remember to dismantle them and then connect them with all these things and then flip the direction. Okay. These are the extra reading for you. If you're not sure how to do it, these are the steps for you to check. Okay, example 4 is application of after you break all the members into free body diagram. These are the steps to go into tension or determine the tension of cable of this one. So first, you draw free body diagram. Free body diagram, you break them into 3 different diagrams. Okay, so you look at A, or you can start with C. C, you have P. So this one P have one cable pull down. Okay, so you pull here this one will have the same cable. Okay, you cut this one. You will see P pull down, tension pull down. Weight, there's a one weight pulling from here on B to A. So there's a force here. So if you don't know whether what you want to put T or you want to put something, if you're not sure, you just put FB. This is B point. So there's a false B point. And if you see the question, do not give you the capital G. There's a no dot capital G. Then you don't need to consider the weight. Okay, you need to look the question. Sometimes the question will give you this G point here. This one don't have. All right. Okay. So then there's a reaction here, go up. There's a cable. So cable, although here is look like a pin, but this pin was connected with one cable. So the force you don't have a C point CX CY, but you have one cable go up here. So that you write as a R or some forces lah. Okay, so this is C. Any question for C? Makes sense, huh? So then you move to B. B is transfer, flip the T. Object C, T move down, so you flip the T, go up. So if you look at B, B got two cable. So two cable pull down. Okay. Just to have a quick solution is when every time you see rope, the arrow always point out from the rope. So that you don't confuse lah. Always point out. Because the cable always in a tension motion. Then A also same. A got 600 Newton pull down. This one P is transfer from B here. All right, so this one flip the direction, and there are two rope here. So this P is transfer from here, and P transfer from here. All right, so you can label as T1, T2, T3, T4, or P1, P2, P3, P4. If you don't want to confuse yourself lah. But basically, this P for object C, P equal to this P. This P equal to this P. It's the same lah. So when you do analysis, you do equilibrium. So you look at one object by one object. You don't solve this one because you don't have value. You still arrive at one equation. This one also. But this one you have 600. So you start with A. So why we don't use Fx equals 0? Because no x direction. So you should able to work smartly. This one in y direction, all the force in y equals 0. Okay. So you can solve. This one got 3p. 3p equal to 600. 1p is 200. Okay, write the working. Write the working. So once you have the p, move to the next one. Right. So 200, 200. T is 400. Okay. T is 200. T is 400. So 400, 400, 400, 200, 200. What is your R? Huh? If you have all the force in Y0, what is your R? R will be? So you have P 400, P 200. What is your R? Huh? Yeah, okay. 100, huh? So it's not 600, it's 800. So 200, 200, 400. Yeah. Okay, so this is how, but anyway, this is too simple lah. This is too simple. This one another example. So you have a distributed load. This one will be your test 2 or final exam kind of standard. You will see distributed load. You will see focus load. So here you have a connector there at point B. So there's a beam, determine the component reaction and support, ignore the weight and thickness. So ignore the weight means there's no central of mass effect, right? So to solve this one, you need to draw it in the free body diagram first. So this one inside the wall cannot move left, right, cannot rotate. So have AX, AY, and moment at A. Okay, the direction of moment, we assume anti-clockwise positive. We assume lah. Of course, you have to see this diagram, whether positive or negative lah. So this one, C is CY, go up. And this one press down. This one also almost press down also. Right? So when this side press down, this one press down, what will be this rotate to? Will be rotate clockwise, right? So clockwise, to balance the clockwise motion, the moment will be anti-clockwise. This is a logic, early hypothesis. But if you really don't know, just assume moment is anti-clockwise. Then you do calculation, you get negative, you need to flip the diagram. Okay? So same, start with the free body diagram. Okay, break them into two components. Okay, before you break, you can do the early analysis first, the whole object with all the forces and AX, AY, and C point up. Then after that, you break into two components. When you break into two components, there is a M, A, AX, AY, copy 10 kilonewton at a certain degree. And BX, BY here, it depends on how you draw it. So for example, you start from C, CY, change the distributed load into focus load. When you draw free body diagram, change distributed load into focus load. So if you forget, if you write in your free body diagram for member BC, you write 4 kilonewton per meter. You draw the four lots of arrow here. I will circle this one, means you wrong step here. Okay, if this one 2 mark, I will circle this one minus 1 mark here. So you only get 1 mark for this free body diagram. Okay, so there will be a minus mark if you do not transfer from distributed load into focus load. Okay, remember this one. Then this one, you can BY move up or BX move to the left. No issue. Okay, what I want to see is the pin at B between the two member. The arrow must be opposite direction. That is what I want to see. Okay, if you draw BX point to the right, BX for the AB member will move to the left lah. That is what I want to see. But normally, we call it a textbook common sense. If you dismantle the object, we always assume the two member like tends to join together. So the arrow will always push like this. If we even though we cut the member or we have a pin, we always assume that the two member want to join together. Okay, so start to practice this BX and BY always pointing to each other. This is a common we call it common sense, positive sense. Yeah, so have this kind of practice for BX direction. So when you cut the things or you remove the pin, try to imagine that actually the two member tends to join together. So the arrow pointing each other rather than push away. Okay, so this is a common sense or correct method of doing analysis in the structure analysis. Okay, then the BX, BY, the BY, it depends as long as they are opposite direction. Okay. I think the rest you already know. Then how you solve for all the unknown. So how many unknown you have? You have CY, BY, BX, AX, AY, and moment. You have 1, 2, 3, 4, 5, 6. You have 6 unknown. You have 6 unknown. Um, yeah, so you have 6 unknown. Then you try to solve using equation of equilibrium, right? So you solve it using segment by segment, okay? Segment by segment. So the rest is still the same. So it's in this case, if you look at BC segment, because we have a lot of unknown here, so we put our moment here. We close our hand here. We only see Cy and 8 kilonewton. So this one generate moment, Cy multiplied by this length, 8 kilonewton multiplied by half of the distributed load. Okay, and have a sense in this, and that one B anticlockwise is positive. So from there you can solve Cy. Once you solve Cy, you can use all the force in x equals 0, or the force in y 0 to solve By and Bx. Okay. Of course, in this case, you know Bx 0. If you see this member, Bx 0. Okay. Same with AB, also same. Because this one have a lot of unknown, we close moment at A. So we have this one split into x and y. This one split into 10 kilonewton split in x and y. Then you have moment. So this one you create 2 moment. Bx don't create moment, By create moment. So these are the answer if you do the calculation. Okay, so try to get the concept lah. Important is you know how to solve. Okay, any question for example 15? No, okay. The rest is just for your homework. If you want to do, you do. With this, we conclude chapter 8. Next lecture, we do centroid. We do finding the center of mass of the body. Okay. Sign your attendance. See you next week. Okay, your test 2 will be in week 13. Just for your info.